Hello everyone. Today we are going to analyze this frame using cantilever method. In this frame, the columns have different cross-sectional areas. In both of the stories, the first column has the area A, the second column has the area 3A, and the third column has the area 2A. In this frame, there are two lateral point loads, 40 kN in the point G and 24 kN in the point D. Now let us see the assumptions in the cantilever method. Point of contraflexure occurs at the middle of all of the members of the frame. For each story of the frame, the interior columns will take twice as much shear force as the exterior columns. In this frame, let us name the center of the columns in both of the stories. You can see that I have named the center of the columns as J, K, L, M, N and O. Now let us split the frame into two parts. From the center of the columns in the top story, let us take the upper part. Now let us find the location of center of gravity x bar. I am going to find x bar from the left side. For the member GM, the horizontal distance is 0. We have to multiply 0 with the area A. A into 0, we will get 0. For the member HN, the horizontal distance is 4. We have to multiply the horizontal distance 4 with the area 3A. For the member IO, the horizontal distance is 4 plus 8. We will get 12. We have to multiply the distance 12 with the area 2A. In the denominator, we have to add all of the areas. So A plus 3A plus 2A. When we multiply these two, we will get 12A. When we multiply these two, we will get 24A. 12A plus 24A, we will get 36A. When we add these three, we will get 6A. We can eliminate A. 6 are 36. So for x bar, we are getting 6. So the distance between the center of gravity and the member GM is 6. The distance between the member HN and center of gravity is 6 minus 4. We will get 2. And the distance between the center of gravity and the member IO is 12 minus 6. We will get 6. Let us keep the axial force in the point M as Vm, in the point N as Vn, and in the point O as Vo. We know that on the left side of center of gravity, the axial forces will be tensile, and on the right side it will be compressive. We know the assumption: the axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. We know that stress is equal to force upon area. For the member GM, the stress is the force Vm upon area. For the member HN, the stress is Vn upon 3 area. And finally, for the member IO, the stress is VO upon 2 area. Now let us apply the centroidal distances. For the member GM, it is 6. For the member HN, it is 2. And for the member IO, it is 6. We can eliminate area. 1 into 6, we will get 6. 3 into 2, we will get 6. 2 into 6, we will get 12. Let us take these two terms. We can eliminate 6. So Vm is equal to Vn. Let us take these two terms. From these two terms, we can make the expression Vo is equal to 2Vm. Now let us take moment about M. In this case, we are moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. Vo is acting in the anti-clockwise direction, so that will be positive, and the distance is 12. So 12 Vo. Vn is acting in the clockwise direction, so that will be negative, and the distance is 4. So 4 Vn. This point load is acting in the clockwise direction, so that is also negative, and the distance is 2.5. For Vo, we can apply 2Vm, and for Vn, we can apply Vm. After the calculation for Vm, we are getting 5 kN. We know that Vn and Vm will be having the same value, so Vn is also 5. We know that Vo is equal to 2Vm, so when we multiply 5 with 2, we will get 10. In the top story, above the center of the columns, we have calculated the axial forces. Below the center, they will be acting in the opposite direction. Now let us split the frame into two parts. From the center of the columns in the bottom story, let us take the upper part. We know that the axial forces in the points M and N are same. Similarly, the axial forces in the points J and K will be same. Also, we know that the axial force in the point O is twice the axial force in the point M. Similarly, VL will be equal to 2 times Vj. Now, let us take moment about J. VL is acting in the anti-clockwise direction, so that will be positive, and the distance is 12. So 12 VL. VK is acting in the clockwise direction, so that will be negative, and the distance is 4. This load is acting in the clockwise direction, so that will be negative, and the distance is 5 plus 1.25. We will get 6.25. This load is also acting in the clockwise direction, so that is also negative, and the distance is 1.25. For VL, we can apply 2 Vj, and for Vk, we can apply Vj. After the calculation for Vj, we will get 14 kN. We know that Vj and Vk will be having the same value. And we know that VL is equal to 2Vj, so we have to multiply this with 2. When we do that for VL, we are getting 28. Let us apply the axial forces. Now we have calculated. Now using these axial forces, we can find the shear forces in the beams. First, let us find the shear force in the member GH. For that, let us take the joint G. Let us apply the rule sigma V is equal to 0. Let us keep the unknown shear force as V. 5 is acting downwards, so that will be negative. V is acting upwards, so that will be positive. Finally, for V, we are getting 5. Let us apply that. Now, let us find the shear force in the member HI. For that, let us take the joint I. V is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. Finally, for V, we are getting 10. Let us apply that. Now, let us find the shear force in the member DE. For that, let us take the joint D. This force is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. The shear force V is acting upwards, so that is also positive. Finally, for V, we are getting 9. Let us apply that. Now, let us find the shear force in the member EF. For that, let us take the joint F. 10 and V are acting downwards, so both of them are negative. 28 is acting upwards, so that will be positive. Finally, for V, we are getting 18. Let us apply that. Now, using these shear forces, we can find the moments in the frame. We know that the moments in the beams will be acting in the clockwise direction and the moments in the columns will be acting in the anti-clockwise direction. First, let us find the moments in the beams. For that, we can use the formula WL upon 2. First, let us take the member GH. Here we have to find MGH and MHG. In this member, W is 5, L is 4. When we apply the values in the formula, we are getting MGH and MHG. Now let us take the member HI. Here W is 10 and L is 8. When we apply the values in the formula, we are getting MHI and MIH, which are 40. Now let us take the member DE. Here W is 9, L is 4. When we apply the values in the formula, we are getting MDE and MED, which are 18. Now let us find the moments in the member EF. Here W is 18 and L is 8. When we apply the values in the formula, we are getting MEF and MFE, which are 72. Now let us find the moments in the columns. First, let us take the member GD. If this moment is 10, MGD and MDG also should be 10. Now let us take the member HE. We can find MHE and MEH by adding these two moments. When we add, we are getting 50. Now let us take the member IF. If this moment is 40, MIF and MFI also should be 40. Now let us take the member DA. We can find MDA and MAD by subtracting this moment by this moment. When we do that, we are getting 8. Now let us take the member EB. We can find MEB and MBE by adding these two moments and then by subtracting this moment. When we do that, we are getting 40. Now let us take the member FC. Here we can find MCF and MFC by subtracting this moment by this moment. When we do that, we are getting 32. In this analysis, we have calculated all of the moments. Also, we have calculated the shear forces in the beams. Now, let us find the shear forces in the columns. First, let us find the shear force in the column GD. For that, we have to add these two moments, so 10 plus 10, and then we have to divide by the height 5. When we do that, we will get 4. Now let us take the member HE. Here we have to add these two moments, so 50 plus 50, and then divide by the height 5. When we do that, we will get 20. Now let us take the member IF. Here we have to add these two moments, so 40 plus 40, and then divide by the height 5. When we do that, we will get 16. Now let us take the member AD. Here we have to add these two moments, so 8 plus 8, and then divide by the height 2.5. When we do that, we will get 6.4. Now let us take the member EB. Here we have to add these two movements, so 40 plus 40, and then divide by the height 2.5. When we do that, we will get 32. Now let us take the member FC. Here we have to add these two movements, so 32 plus 32, and then divide by the height 2.5. When we do that, we will get 25.6. In this analysis, we have calculated all of the shear forces. Now, using the shear forces in the columns, we can find the axial forces in the beams. The axial forces in the beams will be compressive. Now, let us find the axial force in the member GH. For that, let us take the joint G. Let us apply the rule sigma h is equal to 0. 40 is acting towards the right side, so that will be positive. Let us keep the unknown axial force as H. The axial force and this force are acting towards the left side, so both of them are negative. Finally, for H, we are getting 36. Let us apply that. Now, let us find the axial force in the member HI. Let us take the joint I. H is acting towards the right side, so that will be positive. 16 is acting towards the left side, so that will be negative. Finally, for H, we are getting 16. Let us apply that. Now, let us find the axial force in the member DE. For that, let us take the joint D. 4 and 24 are acting towards the right side, so both of them are positive. H and 6.4 are acting towards the left side, so both of them are negative. Finally, for H, we are getting 21.6. Let us apply that. Now, let us find the axial force in the member EF. Let us take the joint F. The axial force and 16 are acting towards the right side, so both of them are positive. This force is acting towards the left side, so that is negative. Finally, for H, we are getting 9.6. Let us apply that. So, in this analysis, we have calculated all of the axial forces. Now, using the moments, we can draw the bending moment diagram. Here I have drawn the bending moment diagram for the columns. Here for the beams. Now we are going to end this session. Thank you for watching this video.